Hi everyone, today we're going to be talking about production possibility curves. And so what we have here is the production possibility curve of Boeing airplanes versus Toyota cars and trucks. And since this is only for an 8-hour period, I've increased the ratio of cars made in 8 hours and airplanes makeable in 8 hours. So we have a maximum possibility of 5 cars or trucks for 8 hours and 1 Boeing airplane for every 8 hours. And so in order to make this a production possibility curve, we have to label the maximum efficiency of Boeing airplanes given that we produce no cars and trucks, which is 1, and the maximum possible produced cars given that we produce no airplanes, which is 5 cars or trucks. And so now to make this a production possibility curve, of course, we can just connect it, and there's the production possibility curve that we have now for the production of cars and trucks at Toyota versus Boeing airplanes. And a lot of the resources used in the production of both of these are very similar. We have batteries made from lithium, we have iron used to make steel, the chassis of the car, the chassis of the plane even. Lots of leather, lots of rubber for the tires too. And so a lot of the materials used in both of these products are incredibly similar. So that will also mean that if we have a loss of production ability for the one, that we also will have a loss of production ability for the other in most scenarios. But the first thing we're going to be talking about is the production possibility point if we have employees using Snapchat and Facebook while they are at work. So what this means is, instead of reaching our maximum possible efficiency, which is along the production possibility curve, we have employees who are not paying attention or not being efficient enough at their job. So instead of reaching, say, a production possibility point over here, and reaching maximum efficiency, what we'd have in this case is probably something along the lines of that. And we'll call that production possibility of, we'll call it Facebook. Okay, so that's the production possibility, or one of them, if we have employees who are not paying attention. And the reason this is because if they were constantly focused and constantly producing and checking the machines and everything like that and making sure the assembly lines and everything was correctly assembled, then we could get out maybe 1 or 2 more cars a week than we could otherwise. But if they're not paying enough attention and there's time wasted in the assembly process or anything like that, then we can't actually hit 5 cars or 1 car produced per hour or any mix of, a little bit less than 1 Boeing airplane and maybe, maybe just a couple trucks. And so we can't do that anymore, though, or we can't hit peak efficiency because we have employees who are wasting time. And so the next scenario we have is change in production with an electricity outage. So if we lose electricity, that's going to affect both the production possibilities of Boeing airplanes and Toyota cars and trucks. Now, the reason this is because both of these require electric machines, so large assembly plants, in order to move a lot of the parts, and then they require people to come in afterward. So if we lose this for 3 hours, then that's essentially 3 hours that we have of nothing working. So we'll actually just go ahead and round it up to 4 hours. So we have an 8-hour workday. Let's say we lose power for 4 hours. What that's going to do, since this affects both Boeing and Toyota cars, is that's going to literally have our total possible production. And that's going to be the production possibility with 4 hours of electricity. So now in scenario 2, but this only happens because we have two goods that rely on electricity uniformly. If we had Boeing airplanes and a carpenter, then the carpenter would be unaffected and the production possibility curve would still reach all the way out toward the 5 Toyota cars and trucks. But since this is cars and trucks instead of a carpenter, we lose production, or we lose efficiency, we lose everything if we are unable to run our factories for 4 hours. That's half of our efficiency, so we literally can only do half as much. And finally, we have the last scenario, which is what's another thing that would affect or reduce the productivity in both of these? And so the example that I'm going to give is we're going to go with an worldwide iron shortage. Now, since we have a worldwide iron shortage, that means it is more costly to produce one Boeing airplane. It is more costly to produce a Toyota car or truck. It's harder to get the materials together. The materials are more costly. Whether or not we even want to use them for the same cars and trucks, the same airplanes, the same models, everything like that will change. And that will affect our production's possibility curve. Just like with the no electricity that pushed it all the way back, now we have no metal. And no metal means that, or low amounts of metal means that we can no longer hit this outer ring of efficiency because we no longer have the materials to even do so. We can't produce this many planes or trucks in an 8-hour period anymore, which means just like our lack of electricity, that we're going to have to shift the possibility production curve inward. And so this time we'll do it like that. And so we'll see it's not quite as bad as losing electricity for half of the workday, but in the long run, we'd rather lose electricity for 4 hours in one workday than have an iron shortage for the next 10, 20 years. So all in all, that's how production possibility curves work. You need to really take into account the kinds of resources that would affect the companies that you're looking at, what they need, because some companies will be a lot less affected by the loss of electricity than others, or say, maybe we don't have depleted iron, but we have depleted wood. Well, that doesn't affect us too much, but once again, going back to the carpentry example, if they don't have enough supplies, then once again, their production possibility curve, their maximum efficiency will fall inward. And if we have employees who are not paying attention, then we can't hit the outer limit of the production possibility curve, because that's maximum efficiency. Anyone who's not paying attention even just a little will nudge the production possibility port from maximum efficiency to less than of maximum efficiency. Alright guys, so that's been the production possibilities curve. Thank you for your time.